Now we're building directly onto atomic structure. This video covers isotopes, ions, and relative atomic mass for paper 1 AQA GCSE Chemistry. All of this links straight back to video 1 on protons, neutrons, and electrons. If you understood that properly, this will feel like a natural step forward.
Look at the two atoms on the right. They both have 6 protons. The number of protons is what defines the element, meaning they are both carbon. Now look underneath. One has 6 neutrons, whilst the other one has 8. The same protons, different neutrons, that's exactly what makes them isotopes. Carbon always has 6 protons, that never changes. Carbon 12 has 6 neutrons, carbon 14 has 8 neutrons. That change in neutrons changes the mass number, but it doesn't change the element. It's still carbon because the proton number hasn't changed. Now look at chlorine on the periodic table. See that 35.5? If every chlorine atom had exactly the same mass, that number would be a whole number. But chlorine has different isotopes. Some are mass 35, whilst others are mass 37. So what you see on the periodic table is a weighted average of all the isotopes combined. That's why it's often a decimal. This is the kind of question that comes up again and again. Out of every 100 chlorine atoms, 75 are mass 35 and 25 are mass 37. We need to calculate the weighted average. If you can work it out, pause the video, have a go, and see if you got the correct answer. We multiply each isotope by its percentage. 35 times 75 gives 2625, whilst 37 times 25 gives 925. Add them together, divide by 100, and we get 35.5. That matches the periodic table value exactly. An ion is simply a charged particle. Look at the atom diagram. When electrons move, the balance between protons and electrons changes. Protons stay the same, only electrons are gained or lost. That's what creates a charge. Look at the orange sodium atom. It loses one electron. That means it now has more protons than electrons, so it becomes positive. Now look at the chlorine atom in green. It gains an electron. That means it now has more electrons than protons, so it becomes negative. Always remember, electrons are negative, so if you lose negative, you become positive. If you ever get stuck on ion charge, use this rule. Charge equals protons minus electrons. Always. Let's apply it. This example has 11 protons and 10 electrons. 11 minus 10 equals plus 1, so the ion has a plus 1 charge. If protons outnumber electrons, the ion is positive. If electrons outnumber protons, it's negative. That's the rule they expect you to use in the exam. Never guess the sign, always calculate it. Let's recap. Isotopes have the same number of protons, but different number of neutrons. Relative atomic mass is a weighted average of isotopes, and ions form when atoms gain or lose electrons. If you understood those 3 ideas clearly, you've secured a solid chunk of paper 1 marks. If you can confidently explain what an isotope is, calculate a relative atomic mass, and work out charge of an ion, then you've just locked in a huge chunk of paper 1 marks. That's this topic sorted, but don't just watch it, make sure you can actually do the calculations yourself. Pause the video, try one, and teach it to someone else. Because understanding this properly now makes the periodic table make so much more sense in the next video. Mr. Knows, knowledge beats luck.